All right, here we go. Scientific notation. This is just a way of expressing numbers. The generic formula for scientific notation, okay? You always have one number in front of decimal. Okay, so let's say you have, the generic formula would be like x, y, okay, any number, x, y, and let's say x, y, z, just for times, it doesn't have to be x, y, z, 10 to the nth power. That is basic scientific notation, all right? Always one number in front of the decimal. These are going to be other significant figures you're going to have in the number, and it's always going to be a 10 to the nth. Could be positive, could be negative, all right? So how many digits should be in front of the decimal? In front, I mean to the left. There should be one number in front, okay? What does it mean to have a positive exponent? Okay, that means it's a large number, large, so big, okay, as in like 1,000, a million. A negative means small, as in these are going to be like decimals. So we're talking decimals. All right. So here's how it kind of works out. How do we change numbers to scientific notation and from scientific notation as well? So let's say we have this number right here, which is what we got, 1, 2, 3. Okay, so this number is 8,800,000,000, all right, meters. Big number. Move the decimal. There's an unwritten decimal here. Move the decimal. Count how many times you're going until there's one number in front, one significant figure in front of the decimal. So I go 1, 2, 3, 4, 5, 6, 7, 8, 9. So we write that down. 8.8 times, how many times did I move decimal? 9 meters. 8.8 times 10 to the 9th meter. This means it's a big number. Is that a big number? Yes, it is. It's going to make it bigger. Perfect. All right, let's try the next one. 9.93 times 10 to the negative 8th. Okay, oops, let's not do that yet. Let's do the other one. So here we have a small number, decimal number. That means it's going to have a negative exponent. So we go here until we get a decimal, a significant figure in front of the decimal. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Really? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I didn't believe it myself. So it's going to be 6 times 10 to the negative 11th kilograms per meters cubed. Oops, sorry about that. To the 11th. All right? That tells me this is a small decimal number. Is it a small decimal number? Absolutely. It's very, very small. Okay? So that tells me how many times I moved it. This exponent tells me how many times I moved it, and then you always got to have one number in front of the decimal. Notice there doesn't have to be numbers after the decimal, just numbers in front. Also, keep in mind, this one has two significant figures. This number shows two significant figures. They have to stay the same. This number shows one significant figure because these front zeros don't count. That shows one significant figure. Those have to remain constant. How many significant figures? 5.93 times 10 to the negative 8th. Ooh, negative 8th. That means I make the number smaller. All right, I have to keep this number of significant figures, okay, the 5.593. So I move it over 8 places to the left to make the number smaller. All right, or you can probably just punch in your calculator too. So we go 1, 2, 3, 4, 5, 6, 7, 8. All right, so it should be, if I did it right, 0.0, and we go 1, 2, 3, 4, 5, 6, 7, 5, 9, 3. That should be my number in, I guess, normal notation, not scientific. All right, so this, notice how negative exponent made the number smaller, made it a decimal, just like this one over here. Negative exponent, small number. 2.5 times 10 to the third, positive number. That means I'm going to make the number bigger, so that means I got to move it to the right 1, 2, 3 times. So we go 1, 2, 3. So we go 1, 2, 3, and that's going to be centimeters. Notice 2 significant figures, 2 significant figures, 3 significant figures, 3 significant figures. That stays the same. If you keep that stuff in mind, you should be good. Realize that scientific notation is not a calculation. All right, not a calculation. So see what you guys know about this stuff. Try a couple of these to see if you can do it. All right, move these to the right scientific notation. This is where you stop the video. This is where you try these. All right, but I'm just going to go through them. So once you stop it, try them, and then check your answers. 200, scientific notation. Well, it would be 2 times 10 to the second. 2.50, 250 with a decimal place, 3 significant figures. 2.50 times 10 to the second. 1,000, 1 significant figure. 1 times 10 to the third. 200,000, no decimals. 2 times 10 to the 6. 1, 2, 3, 4, 5. Nope, 5. That'd be a million. All right, to the 5. Notice how there's decimal. 4 significant figures. 2.100. Got to keep those significant figures times 10 to the third. Now these are all positive, big numbers. Now we're going to negative ones. 0.01. That would be only 1 significant figure times 10 to the negative 2. Okay, 2 significant figures here. End zeros count. 1.0 times 10 to the 1 negative 2. All right, a little different, more precise number. Okay, 2 significant figures, 5.5 times 10 to the, what do we got? 1, 2, 3, 4. Negative 4. 2 significant figures, the 7 and the 0 count, so 7.0 times 10 to the 1, 2, 3, negative 3. Huge number, gigantic number here. Okay, so we got 3, 6, 9, 12, 15, 18, 21, 22, 23. 6.023 times 10 to the 23. And I did skip one, sorry about that. All right, big number. Notice how I kept the same number of significant figures. The 1, 2, 3, 4. Smaller number over here, 2.05 times 10 to the 1, 2, negative 2. All right, let's keep it moving. 3, 6, 9, 12, 15, 18, one more, 19.60 times 10 to the negative 19th. All right, there you go. Hopefully that helps you out. Now you got to do the backwards version. In other words, try to figure out the number from the scientific notation. So we just got to move this number 3 decimal places to the left. So it'd be 3,560, 3,560. 7 points. So we got 982. So it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think I did that right. Big number, it's positive. 8, 34, it's 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, this is kind of a crazy one. So how do we do this one? Well, there's 1, 2, 3, 4, 5. There's 5 significant figures. 1, 2, 3, 4, 5. Line above it. Again, doesn't happen often, does happen. All right, negative numbers. Now we're going to make numbers smaller. So we're going to go 0.123,702. 6.6 times 10 to the 34th. Holy cow. 1, 2. That'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29. We're running out of space. 30, 31, 32, 33, 34. That is a gigantic number. I never want to do that again. All right, 2.030 times 10 to the negative 18th. That's a negative number, so we got to move it. So we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 2, 0, 3, 0. Simpler one, thank goodness. 1, 2, 3, 3,000. And then 1, 2, 3, 4. There you go. There's your numbers. Hopefully it worked out. Hopefully you understood it. It's all about how many you got to move it. Positive ones make it big. Negative ones make it small. Simple as that. All right, so when we're doing this stuff, it says what KSP is the measurement of solubility in salt. The larger the value of KSP, the more salt can be dissolved. Which value indicates the highest solubility? So which is your highest number? So look for your highest exponent usually. So -6, it's -7, -8, -9. Oh, well, that's easy. Which one is the small or the biggest number? And you would say this number would be the biggest, which would indicate the highest solubility. All right, low, the highest one because you have all negative numbers there. When you're doing calculations, you think you have to add these numbers. All right, you can just punch the stuff in your calculator, but it does help to actually know what your calculator is actually doing. All right, and how to punch in your calculator as well. So I'll show you this. See if you can see that in your calculator. I think that's good. See it? Yep. So on your calculator, how you punch this in, all calculators are different. Some will have a double E button. Some will have an exponent button. So you go 5.6 exponent. Okay, that exponent means times 10 to the 7th plus 4.6 exponent to the 8th. So you can just punch all this stuff in your calculator if you really wanted to. And what we got from this number is, this is nowhere near the right answer because this number is rounding it too much. All right. So that's how you do it with the exponent button. Okay. Here's how you do it with a double E button. If you find this calculator like this, which these are great calculators, they're simple, they're great. All right. What you got to do is you got to go 5.6 double E. Sometimes you got to push the second function to the 7th. Then we got plus 4.6 double E to the 8th. Add them together, you get 5.16. So times 10 to the 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8th. Okay, and when you multiply these things, it's really just a calculator answer. Multiplying, you really should be adding the exponents, and you're dividing, so you should be subtracting. All right, so let's quick do those. 4.7. Oh, by the way, this should be 5. This should be 5.2 times 10 to the 8th, because these are all to two significant figures. All right, so 4.7 exponent to the 5th times 7.3 exponent to the -3rd, and I got 3.431 times 10 to the 3rd, which rounded to two significant figures would be 3.4 times 10 to the 3rd. Next one, 1e to the 8th divided by 4.7 e to the 10th gives you an answer of times 10 to the, what do we got? 1, 2, 3. 10 to the 3rd. And if you round the right number of significant figures, here's 2, here's 3, so we go to 2. So it's going to be 2.1 to the 3rd. Then we got 8.2 e to the -4th times 3.01 e to the 5th. This one we get 2.4682 times 10 to the 4. Rounded to, here's 3 figs, here's 2, so we got 2.5 times 10 to the 4th. So there's some answers for you. Hopefully that helped you out, and keep on keeping on.